The moon jellyfish moves through the ocean as if time itself has slowed around it. With no apparent urgency, no visible struggle, and no clear direction, it pulses gently through the water, expanding and contracting in a rhythm that feels almost meditative. To the human eye, it appears peaceful, even passive, a living ornament drifting wherever the sea allows. But this quiet presence hides a survival strategy so ancient and effective that it has endured for more than 500 million years. Long before fish developed jaws, before plants colonized land, before vertebrates ever drew breath, jellyfish already ruled the seas. The moon jellyfish is a living echo of that era, a form so fundamentally suited to the ocean that evolution has found little reason to change it. Its body is simple to the point of minimalism, yet every aspect of that simplicity serves a purpose. Nothing is wasted, nothing is excessive. Its translucent bell, often mistaken for fragility, is a masterpiece of efficiency. Composed mostly of water, it requires almost no energy to maintain. There is no heavy skeleton to support, no dense muscle mass to feed. Instead, the moon jellyfish relies on buoyancy, letting the surrounding water carry its weight. Each slow contraction of its bell pushes it forward just enough to remain suspended, to stay within favorable currents, to encounter food drifting invisibly around it. Unlike predators that chase or ambush, the moon jellyfish survives through constant exposure. It places itself in the path of opportunity and waits. Tiny plankton, larvae, and organic particles brush against its trailing tentacles and oral arms, becoming entangled in a sticky web of mucus and microscopic stinging cells. These stings are mild compared to those of more infamous jellyfish, but they are sufficient. The goal is not to overpower, only to slow, to gather, to consume. There is no brain directing these actions, no central processor calculating distance or timing. The moon jellyfish operates through a decentralized nerve net, a diffuse system that responds locally to stimuli without higher coordination. Touch triggers contraction, contact initiates feeding, light influences movement. The result is a creature that behaves without intention yet responds effectively to its environment, a biological system that reacts rather than decides. Its iconic four-ring pattern, visible through the bell, marks the location of its reproductive organs. These shapes, often compared to petals or moons, are a reminder that reproduction is as central to its existence as feeding. When conditions are right, the moon jellyfish releases gametes into the water, trusting currents to complete the process. There is no mating ritual, no pairing, no care. Survival is statistical, not emotional. This approach extends to its life cycle, one of the most unusual in the animal kingdom. The moon jellyfish does not move from youth to adulthood in a straight line. Instead, it cycles through radically different forms, each adapted to a specific role. From free-swimming larvae to stationary polyps to fully formed medusae, it transforms repeatedly, reshaping itself in response to environmental cues rather than internal clocks. These transformations allow the species to persist through unfavorable conditions. When food is scarce or temperatures drop, polyps can remain dormant, waiting. When conditions improve, they produce new jellyfish in bursts, repopulating the water with sudden abundance. In this way, the moon jellyfish does not merely survive change, it times it. Its presence shapes the ecosystems it inhabits. By feeding on plankton, it competes directly with fish larvae, influencing population dynamics in subtle but significant ways. In regions where moon jellyfish numbers increase dramatically, fish recruitment can decline, altering food webs and commercial fisheries alike. Yet the jellyfish is not an invader. It responds to opportunity created by environmental imbalance, overfishing, warming waters, nutrient runoff. To predators, the moon jellyfish offers little reward. Its body contains minimal nutritional value, and its gelatinous texture provides little energy return. Some species consume it out of necessity, others ignore it entirely. This low desirability further enhances its survival, allowing it to exist largely unchallenged, drifting through a world that has little reason to remove it. For humans, the moon jellyfish occupies an unusual space between fascination and indifference. It rarely stings with severity. It does not threaten swimmers or fishermen. It appears in aquariums as a symbol of calm, its slow pulses mesmerizing viewers. And yet, its growing abundance in certain regions is a quiet warning, an indicator of changing oceans, of systems drifting out of balance. In the moon jellyfish, there is no aggression, no dominance, no conquest. There is only persistence, a body designed to do just enough, a life strategy built on patience, and a rhythm synced not to ambition, but to the ocean itself. The life of the moon jellyfish does not follow a straight path, and this deviation from linear existence is one of its greatest strengths. While most animals move from birth to maturity in a single, irreversible direction, the moon jellyfish cycles through states, pausing, transforming, and restarting when conditions allow. This flexibility has carried it through planetary upheavals that erased far more complex organisms from the oceans. After fertilization, the jellyfish begins as a microscopic larva, drifting briefly before settling onto a hard surface. Here, it becomes something almost unrecognizable, a small, stationary polyp anchored to rock, shell, or human-made structures like docks and pilings. In this form, the moon jellyfish is no longer a drifter but a patient observer, feeding quietly on passing particles while the world changes around it. This polyp stage can last months, even years. It is a biological pause button, a survival mechanism that allows the species to wait out unfavorable conditions. Cold temperatures, low food availability, or chemical imbalance in the water do not end the cycle, they delay it. When the environment improves, the polyp responds not with urgency, but with multiplication. It begins a process of segmentation, producing stacks of tiny discs that eventually detach as juvenile jellyfish, each one a continuation of the same genetic line. This strategy produces sudden blooms, moments when the ocean seems filled with translucent bodies, appearing almost overnight. To human observers, these blooms feel invasive, unnatural, even alarming. But from the jellyfish's perspective, they are simply the result of timing. The moon jellyfish does not spread aggressively, it emerges when conditions signal that survival odds are high. Its movement as an adult remains deceptively simple. The slow pulsing of its bell is not true swimming in the muscular sense. It is a controlled interaction with water resistance, a way of maintaining position rather than covering distance. Most of the jellyfish's travel is passive, dictated by currents and tides. This passivity, often mistaken for weakness, is precisely what allows it to conserve energy so effectively. Feeding follows the same philosophy. The moon jellyfish does not seek prey, it filters opportunity. Its oral arms form delicate channels that guide food toward the mouth, relying on water flow rather than force. The energy gained from this feeding is minimal, but so are the costs. In an environment where energy efficiency determines survival, this balance is everything. The absence of a centralized brain does not limit the jellyfish's responsiveness. Its nerve net allows it to sense changes in light, touch, and chemical composition of the water. These signals influence behavior subtly, slight adjustments in pulsing, changes in depth, responses to obstacles. There is no memory, no learning, only immediate reaction. And yet, this is enough. In many ways, the moon jellyfish embodies a form of biological minimalism. It removes all non-essential functions, leaving only what is required to persist. This makes it extraordinarily tolerant of conditions that would overwhelm other animals. Low oxygen zones, fluctuating salinity, and murky waters do not deter it. Where ecosystems are stressed, the moon jellyfish often finds opportunity. This tolerance has consequences. As human activity alters coastal environments through pollution, overfishing, and nutrient runoff, jellyfish populations in some regions increase dramatically. Reduced competition from fish larvae and increased plankton availability create ideal conditions for blooms. The moon jellyfish does not cause these imbalances, but it capitalizes on them, becoming more visible as ecosystems shift. For marine life, this visibility changes interactions. Fish that once dominated surface waters encounter dense fields of jellyfish, altering feeding patterns and migration routes. Predators that rely on clear water and agile prey find themselves navigating gelatinous obstacles. The jellyfish, indifferent to these disruptions, continues pulsing, feeding, reproducing. Human responses range from fascination to frustration. In some cultures, jellyfish blooms are seen as signs of environmental decline. In others, they are harvested for food or studied for biomedical research. The moon jellyfish, with its simple body and regenerative abilities, has contributed to scientific understanding of tissue repair, cellular organization, and resilience. Yet despite this attention, the moon jellyfish remains unchanged by human interest. It does not adapt to us, we adapt to its presence. Fishing practices shift, coastal management strategies evolve, aquariums display it as an emblem of calm. Through it all, the jellyfish continues its ancient rhythm, pulsing in time with tides rather than trends. In this second phase of its story, the moon jellyfish reveals a truth that is easy to overlook: survival does not always require advancement. Sometimes, it requires endurance, a willingness to wait, a structure simple enough to persist when complexity fails. As moon jellyfish populations expand across modern oceans, their presence begins to reshape entire marine systems in ways that are subtle, cumulative, and often misunderstood. They do not arrive as conquerors, nor do they behave like invasive species pushing others aside by force. Instead, they fill spaces that have been quietly emptied. Where balance erodes, they appear, not as a cause, but as a consequence. In healthy marine ecosystems, energy flows through a tightly woven network of plankton, fish larvae, small predators, and larger consumers. Moon jellyfish sit near the base of this network, intercepting plankton before it can be converted into fish biomass. When fish populations are strong, this competition remains balanced. But when overfishing removes adult fish and warming waters reduce larval survival, the equation shifts. Jellyfish suddenly find themselves facing less competition for the same drifting food. This shift creates feedback loops. Fewer fish mean fewer predators of jellyfish larvae and polyps. More jellyfish mean more plankton consumed, leaving even less for fish larvae trying to recover. Over time, systems can tilt toward what scientists describe as a jellyfish-dominated state, where gelatinous organisms become the most visible, and sometimes most numerous, life forms near the surface. Moon jellyfish thrive in these conditions not because they are aggressive, but because they are tolerant. Low oxygen zones, often created by nutrient runoff and algal blooms, pose little challenge to them. Murky water does not limit their feeding. Temperature fluctuations that stress fish leave jellyfish largely unaffected. Their bodies, composed mostly of water, buffer them from extremes that would damage more complex organisms. This tolerance allows moon jellyfish to act as biological placeholders. They occupy ecological space while more sensitive species struggle. To humans, this can feel like loss, an ocean filled with gelatin instead of fish. But from an ecological perspective, it is transition. The system has not died, it has shifted into a form that can persist under stress. Human industries feel these shifts acutely. Fisheries experience reduced yields. Nets clog with jellyfish, increasing labor and damage to equipment. Power plants and desalination facilities face intake blockages during blooms. Coastal tourism suffers as waters fill with drifting bells, even though moon jellyfish pose little danger to swimmers. Visibility alone changes perception, and yet, the moon jellyfish itself remains indifferent. It does not respond to abundance with excess consumption. It does not escalate behavior when numbers increase. Each individual pulses, feeds, and reproduces as it always has. The collective effect emerges not from coordination, but from accumulation, millions of identical actions repeated across space and time. This indifference is what makes moon jellyfish powerful indicators of environmental change. Their success signals conditions that favor endurance over specialization, tolerance over efficiency. When they flourish, it often means that ecosystems are under pressure, operating closer to their limits. In this sense, jellyfish are not warnings shouted loudly, but quiet metrics drifting into view. Scientific interest in moon jellyfish has grown accordingly. Researchers study their blooms to understand nutrient cycles, climate impacts, and ecosystem resilience. Others examine their simple nervous systems and regenerative abilities, searching for insights into wound healing and cellular organization. Even their translucence has inspired optical research and material science. From simplicity emerges utility. Despite this attention, moon jellyfish do not become domesticated by understanding. Knowledge does not grant control. Efforts to reduce blooms by targeting jellyfish directly rarely succeed, because the conditions that support them remain unchanged. Remove the jellyfish, and more will come, emerging from polyps already waiting beneath the surface. This reveals a difficult truth about environmental management. Systems cannot be corrected at the surface alone. Moon jellyfish are not the problem to be solved, they are the symptom to be interpreted. Their presence reflects choices made far upstream, on land, in policy, in consumption, in the slow accumulation of small impacts. Still, there is no malice in the dominance. The moon jellyfish does not replace other species out of competition, but out of compatibility. It fits where others no longer do. And as long as the ocean continues to warm, to lose oxygen, to absorb excess nutrients, it will continue to fit remarkably well. In this third movement of its story, the moon jellyfish becomes something more than an animal. It becomes a measure, a drifting gauge of ocean health. A reminder that when systems change, life does not disappear, it rearranges itself. In the quiet presence of the moon jellyfish, there is a lesson that resists urgency. It does not demand attention. It does not announce danger. It simply exists, pulsing gently through water that has changed around it. And in that existence lies a truth that modern humanity often struggles to accept. Survival does not always favor those who act the fastest, think the hardest, or build the most. Sometimes, it favors those who endure. The moon jellyfish has no ambition. It does not expand its range with intent, nor does it retreat with fear. It responds to conditions exactly as they are, not as they were, and not as they might become. This radical presence in the moment is not mindfulness in a poetic sense, it is biology stripped of narrative. Where humans layer meaning onto every change, the moon jellyfish accepts change as a constant. This acceptance is why it feels almost timeless. Watching one drift in an aquarium or open water creates the illusion that nothing is happening, that time itself has slowed. But beneath that calm exterior, processes unfold with precision. Cells divide, nutrients circulate, signals pass through nerve nets. Reproduction waits patiently for the right moment. Stillness is not inactivity, it is efficiency. Human perception often mistakes calm for weakness. We equate power with motion, dominance with disruption. The moon jellyfish offers a different model, one where minimal force produces maximum longevity. Its body avoids conflict not because it cannot fight, but because it does not need to. It has evolved into a form that sidesteps competition entirely, thriving where others falter. This has implications far beyond marine biology. In an era defined by acceleration, faster technologies, faster decisions, faster consumption, the moon jellyfish stands as an anomaly. It has survived planetary upheavals without innovation, adaptation in the human sense, or conscious strategy. Its success is rooted in restraint, in doing only what is necessary, in never overreaching. There is discomfort in this realization. If such a simple organism can persist while more complex systems collapse, what does that say about the direction of progress? The moon jellyfish does not offer solutions, but it reframes the question. It suggests that resilience may lie not in adding layers, but in shedding them. Not in control, but in compatibility. As oceans continue to transform under human influence, moon jellyfish will likely remain. They will drift through warming waters, through altered currents, through ecosystems reshaped by loss and imbalance. They will not mourn what disappears. They will not celebrate what replaces it. They will pulse, feed, reproduce, and wait. For humans, encountering the moon jellyfish can be strangely grounding. It does not threaten, yet it does not comfort. It simply reminds us that nature does not revolve around our preferences or our timelines. Beauty does not guarantee safety. Calm does not imply fragility. And persistence does not require intention. In the end, the moon jellyfish is not a symbol of decay or decline. It is a symbol of continuity. A living thread connecting ancient oceans to modern seas. A form that has proven, over and over again, that survival is not always about change, but about knowing when change is unnecessary. It drifts on, silent and translucent, carrying no message, offering no warning. And perhaps that is its greatest power. It does not teach by instruction. It teaches by example.